let's talk about it. This is a quite extraordinary instrument. We seem to have bells going. Is that okay? This is quite an extraordinary instrument. Some of you will know about the construction of musical instruments, many won't. But we need to explain a few things to why this is such an extraordinary thing. And together with the maker of this instrument, Jeff Stelling. So Jeff, do you want to join us? Let's just, if I may, David, could I just start with Jeff to explain technically what's going on here, exactly what has happened, and then we'll come back to exactly why it's necessary. Can you do that for us, Jeff, just to explain the instrument itself physically, technically?
Sure. What we've done to make this instrument an extension of David, something that is very intuitive, is we've combined the main body. The main body is broken up into the upper stack or the left hand, the lower stack and the right hand, and we need to be able to transition between the two and play keys of both ends at the same time. So we've overcome that problem by creating what we call the toggle key, and it is able to, in one key, play the left hand number 1 up or down, or the right hand number 1 up or down, and then both of them together in one key. So each key has 6 functions, essentially. So he's able to play this part of the instrument with 3 keys. And then around those toggle keys, we have the palm keys located below them, which are up here. Then the back side keys on top. Then the bow. This is the bow. Those keys are played underneath. And then the bell keys in the back with his thumb. His thumb actuates the octave key and then both bell keys. And then it's all in a form that he's able to do quickly and get between them. Other people have done different designs as old as 150 years ago, and they did it similar to ranks on an organ, where there was an upper set of keys and a lower set of keys, but getting between the two was very cumbersome. So the toggle key allows you to switch between the two seamlessly at any speed necessary.
And it's not just the mechanical invention here, it's also materials that you've had, problems with that you've solved.
Correct. This is the second version. The first one added about 2.5 pounds of weight to the instrument, which really becomes taxing to the neck. So what we did is add carbon fiber. And so we have carbon fiber on the front, the back, and the side to transfer motion.
But you can't just connect the carbon fiber straight to the brass, can you?
No, we have to have transition pieces in stainless steel, special ferrules on the end, because these carbon fiber shafts are actually arrow shafts, and the fibers run longitudinally, so they're not designed for torsional twists. So we had to develop spars actually on the outside and then combine them to the brass so that we could connect to the keys. Also, they require adjustment because the carbon fiber can't be twisted, to be adjusted, so the brass allows for adjustment.
Easy, eh?
Yeah.
So, and then you've got the way to put this hand, which I know some of the instruments don't have. In fact, it's being played by some amputees who have no other hand to steady the instrument at all. But that has caused the shift of the bell. Is that right, or would you have to shift it anyway?
No, we shifted the bell. Actually, the entire horn. If you look at a saxophone, normally the neck would come out, the body comes straight down, and the bell comes forward. What we had to do was change that direction about 15 degrees, so the bell has come over, the neck has come over, so that the toggle keys are in the proper position for your hand, and to also have enough clearance to clear the bell. The handle is an offset of the...
Now, this is a saxophone. Can you use the toggle key system for other instruments?
Yes, you can use them for clarinets or flutes. Actually, on flutes, the key itself becomes a bit heavy and cumbersome, so instead of the key, we use the same concept, only with rollers in the same position that the toggle key is. Clarinets present a specific problem because most of them are open hole, except for bass clarinets. There are some plateau, that means covered hole clarinets that are hard to come by, but you can adapt those. Really, any instrument is adaptable, but they all present their own problems, their own hurdles.
David, why was this necessary? You were
I'm a trained musician.
Yeah.
I studied musical performance and music education. I had a PhD in music education and was a music professor since I was about 33. At the age of 37, I was in perfect health. I was thinner than I am now, and suddenly one day I was talking on the telephone. I had a major stroke, and my entire left side was completely paralyzed. A very serious stroke, and there was no prognosis for they could not predict any kind of recovery. So clearly I've made a good recovery. I'm very grateful for that. However, my left hand is no longer perfect, and I can no longer make music the way I used to. And so this instrument is very interesting technically, but it's very important emotionally and professionally to me, because it allows me to return to my profession and something that is very deeply ingrained in my soul. I'm not playing this instrument just to show that it can be done. I'm doing this out of total necessity.
And do you have other pupils and colleagues who've also, with other injuries or difficulties, disabilities, have also used the saxophone?
Jeff has made 3, and he's building his 4th Toggle-Key Saxophone. The other 2 existing Toggle-Key Saxophones are both in use by permanently disabled people. There's a young girl who's 15 years old now, who went on a ski trip when she was 14 years old, took a spill, what looked like a minor fall, but she tore all the nerves in her left shoulder plexus area, and they can't be reattached. She no longer has any movement in her left arm, and she's playing one of the Toggle-Key instruments in her school musical groups, in jazz band and concert band and solo. And she aspires to become a professional musician because this technology has made that possible for her. There's a separate gentleman who had a stroke when he was 27. He was a trained music teacher, suffered a major stroke, and commissioned a saxophone from Jeff, and is having fine success with that as well.
I want to just address the rest of the OHMI mission and competition. If you'd like to sit for a while, and we'll come back to you a bit later, if we may. So the OHMI Trust was formed in recognition of a problem about music and disability. And the issue is that every traditional musical instrument, you can scratch your heads for the exceptions if you can find any, requires 2 highly functioning hands and arms to play. If you have any deficiency, you're already limited. You may not be able to play at all in the case of an amputation or being hemiplegic or quadriplegic. You may be able to play to some degree if you have arthritis or severe rheumatism or a minor injury, but you're prevented from reaching the highest pinnacles of virtuosity. The OHMI Trust has been formed to provoke the creation of instruments which will allow disabled people to perform at the highest levels, unlimited, as you would if you are any physically normal person. Now that is actually an extremely difficult thing to achieve. We've focused it on one-handed instruments, so-called. Actually, the competition says instruments should be played without the use of one hand or arm, but we wanted a very, very tight focus on it so everybody knew precisely what the challenge was. But actually what's happening is we're producing technological solutions which can be sort of reconstructed to suit a vast range of disability. And we have 2 categories of award. One is the playable, which David and Jeff have won. The other is a category we call the concept award. And this is for ideas or technologies which have lead us towards solutions for playable in the future. I'm going to quickly run through these. I better keep an eye on my time as well. we have 3 winners this year. Just quickly go through these. Laurel Pardew this is a PhD project started at MIT, being finished at Queen Mary University in London. The virtuosic hand controller, and she's developed this, well, it's like a glove actually, but she's sort of demounted it to show this. You've got micro movement control in these sliders in one hand, but also a sort of macro movement by moving the arm itself. So you've got 2 measures of control. There's also in these trumpet-like pistons, there's also haptic feedback, which is an essential characteristic of being able to control your musical output, being able to achieve musically what it is that you emotionally want to put into it. You need that feedback. So this is still at a very developmental stage, but it is operating. On our website, by the way, there is a paper from Neem that she published, presented there. That paper is on our website, and a lot more detail about all these instruments there. A much simpler instrument, Ruud van der Wel from Rotterdam. He's mostly dealing with teaching young people with muscular dystrophy. He's developed a very simple instrument. He used a Yamaha wind controller, which you can see one of his pupils playing there. But he's added a switch. This case is on the table in the photograph, but it's usually used by the foot. And all it does is toggle the notes. So you get 2 notes out of 1, basically. But with the reach that you have from the Yamaha wind controller, you can then produce a chromatic scale out of it. You need another controller, though, to change octaves. It's a very basic bit of equipment, but it's an extremely simple thing, and it does work extremely well. Then we have this. In sophistication, this is the other end. This is an extremely sophisticated instrument that you can buy now. It's available in the shops. It's produced by Eigen Labs. They have 3 instruments. This is the Eigenhardt Pico, which is the smallest of them. At the moment, they're not programmed for use for either one hand or for emulation of classical or traditional musical instruments. It's purely electronic output, which is why they're in concept and not in playable. But it's really worth a look on the website. There's a presentation there by the creator of this instrument, exactly how these keys work. But they're all optically read. They move in 4 ways. Each key depresses, but can then rotate in 4 ways, and that movement is optically read underneath and produces a very high quality digital output. There is programming in the device itself, which produces a selected sound that you wish. You can combine those sounds. You combine it with wind that you can see. You can blow at the top, which actually has 3 sensors in it, 1 measuring the air through and 2 others measuring pressure. So you've got a greater range, and this fingerboard on the side here. There's a huge range of things. We are working on a program to develop it as a classical emulator, which is a program we hope to finish by next year. So the Concept Award is a fascinating territory, throwing up adaptations, such as the saxophone, completely electronic solutions, which are complex because of the partition of difficulty between the input, the processing, and the output, and how you achieve that, and how you would eventually achieve it if you were, say, sitting in an orchestra or sitting in a rock band or a jazz band. That you've got that visual as well as volume, as that is in terms of mass, power supplies, lots and lots of technical difficulties, and we have hybrids that are being used, presented as well. If there was more time, I could go through some of the other entries, which are some extraordinarily imaginative. But that's the concept. But of course, the aim of all of this is about playable instruments, about taking disabled people into the orchestras, which they are currently completely prevented from participating in by, well, I'd say by the instruments we have to play. It's often put to me that their difficulty is about their disability. I say that's not the case. The difficulty is the instruments that we have for people to play of different physical characteristics. So David, this is a fantastic instrument, and I'd really like to just finish my 15 minutes with some more saxophone, if you would.